Okay, so last lesson, if you guys can remember that far back, okay, we obviously gave you your sack marks, but we were looking into finding the area of your composite shapes, which is this chapter here. Okay, we started as well on looking at some of the shapes that you'll see in the sack and some principles that you'll be using in the sacks. For example, here for these shapes, what we did was we broke it down into two separate shapes. So, firstly, you try to identify what shapes you're working with. Yeah. So what I did here is I broke it down. Okay, and I think Junior answered this before. What are the two shapes that we're working with here? Tell me, Junior. What are the two shapes that you can see here? Kind of. It's a square. Good. And what's this one? It's a semicircle. Good. So what we did was we broke it down into a semicircle. Find the area. Jeremy, Jacob, Jordan. Okay, and then a square. Find the area. Okay. So it's really important that you do that because you need to understand what sort of formulas are you going to use to find the shapes, the area of the shapes. And also that handout I gave you, which was this, should help you to figure out what shapes you're using, okay, or you're going to be finding the areas of. And also as well, we worked with some crazier shapes that were a bit trickier than a semicircle or a rectangle or a square. We had shapes like this, okay, where you've got a full rectangle, but then there's a little cutout. So what we did here is we found the area of the whole rectangle, found the area of the little cutout, which is that one there. Okay, and then we took it away. We minused it to find the area. I think it was Jeremy or Jacob that said, oh, you could actually do three shapes here, which is also correct. But the easier way to do it is to just find the total area and then minus the little bit that you don't need, which is that, okay? So sometimes you'll need to do that. And then we did that with these shapes. All right, so if you remember, we found this shape, for example, here is a rectangle, but then you had to take away half a circle, take away another half circle, and then add a half circle there, okay? This shape, for example, here was a weird teardrop shape. So what we did was we found half the circle only, which was that, okay? Then we took away this bit, this circle, and then we added this part of the circle, and that gave us the total area, which was on the side here if you want to find a working out. So there. All right, now we're going to get into the next part, which is your surface area. And the reason why I went through all of that stuff initially just then is because all of that relates to what we're learning about here in surface area. So our intention is to be able to solve surface area, okay, which is basically finding the area of the surface of a shape. That's what this word implies, surface area. So the surface, the outside, and then the area of a shape. So this is now working with 3D shapes. Okay, so 3D, all right, that's 3D surface area. So when you're working with a three-dimensional shape, what we're trying to do here is find the area of the outside of it. And when it says here area of right prisms and cylinders, it just basically means simple shapes like a cylinder, a cube, a rectangular prism, a triangular prism, a pyramid. Those are all right prisms. And so as our success criteria, I would hope that you'd be able to at least draw the net of a 3D shape. You've probably seen that word before, net. Okay, we'll get into that in a second. Identify the dimensions of each section. So dimensions mean what's the length, what's the width, what's the height of a certain shape. Next is to also be able to calculate the area of each part, okay? That's part of what it means to look for the surface area. You need to calculate the area of certain parts of a shape and then obviously apply all of that. So there's going to be rules that we can use to find surface areas, right, to many shapes. All right, so what I'd like us to do, now the answer's already kind of there, but I would like us to pick a shape here. Out of these ones, pick one, and I want you to draw the net for it down here. If you don't know what a net is, it's basically the unfolded version of a 3D shape. So let's say, for example, for a cube, okay, if I drew a cube right here, okay, there's my cube. The net version of it would be, we know that a cube has 6 faces. So technically, the cube will have 6 unfolded faces there. So 1, 2, 3, 4, 5, 6. See, if you unfold it, it should have those 6 faces. Okay. See if you can do any of the other 3. So just pick one and see if you can do it. 3D shape you work with, whenever you draw the net for it, is essentially just a composite shape. So you can look at the same examples here. Composite shapes. Okay, for a cube that you turn into a net, there's 6 square faces. For a rectangular prism that you turn into a net, there's 1, 2, 3, 4, 5, 6 faces as well, even though they might be slightly different. Just a FYI, for any rectangular prism, you'll find that there are 3 pairs of sides that are the same. So you've got 1, that's the same. These 2 are the same. And these are the same. Okay, so just bear that in mind. For a triangular prism, okay, you've got 3 rectangles and 2 triangles that you're going to have to find the area of, put them together. And for what Jordan's did, sorry, he had 2 circles, okay, and then he had 1 rectangle to add together to find the area of, okay. So it's essentially, again, just finding the area of a composite shape, because that's all what a net is. All right, we won't do these ones. Okay, so when you're adding the surface area of a prism, okay, this is a key idea that you can use. It's basically the sum, so the sum just means altogether, of the areas of the bases and the lateral faces. So when you talk about the base, you're talking about the top and the bottom of the shape, plus its sides. Okay, all these sides. That's all you're doing when you're adding surface area. So it's the top, the bottom, and all its sides. Okay, that's all you're doing for any 3D surface area question. All right, so here we're going to look at some formulas that you can use to find the areas of certain shapes. Okay, so here, for example, a rectangular prism. You can do it this way if you want to, but you don't have to. Okay, it says here, label each side of the net with its corresponding dimension and calculate its surface area. Then use your drawing to write a formula of the surface area of a rectangular prism. Let's actually put that to practice. So here is this shape here. Okay, so just watch it for now. Don't have to do anything. I'm going to redraw that here. So you've got a very nice rectangular prism. Okay, and understand the dimensions here. You've got a length of 6. So that means this long side here is 6. You've got a width of 3. So that means this length here is 3. And then you've got a height of 5. So that means this length here is 5. And they're all in centimeters. Okay, so what you want to do is you only be able to find the net version, okay, of your rectangular prism. So you can redraw the net, and I'll go through that now. So if you try and redraw the net of this, okay, it would look like this. So you've got your basic rectangle, and then you'll have one side here, another side here. You'll have this side, and then you'll have a side on the top, and then a side on the bottom. Okay. If I tried to color code this, that might make it easier. So I'm going to do that actually. So I'm going to rub this out real quick. I'm just going to color code it so it's easier for you guys. So you've got this face, okay, and then you've got this face. The ones, the way that it's color coded, the ones that are the same color are the same or corresponding sides. You've got this side. So what that tells you is if you look at it, for example, a triangular prism, you've got these sides that are the same. So this side and this side are the same. This side and this side are the same. This side and this side are all the same. So you've got pairs that you're working with, okay? So whenever you find the area of one of the faces, you technically should multiply it by 2. Well, let's put in the dimensions for now. So I know that this length here corresponds with the length of this whole thing. So this should be 6. This length here, this length here, okay, should be 5. Okay, why is that 5? Well, if you think about it, this length corresponds with this length. So that means it's actually this side that is the same width. So that's 5. And then the next side that we're working with is the width of the actual shape. So this is going to be 3. Now it's not to scale, but that's okay. So now that should be enough information to find the areas of. Okay, let's look at the first shape. Let's look at the first rectangle. So the first rectangle I can see, let's work with the red ones. So I'm just going to draw like this. Actually, let me draw like this so it's not confusing. Draw the red ones. And I can see that the red ones have a dimension of 6 by 5. Now, how many red rectangles do we have here? So I have to multiply my answer by 2 when I do this. So remember, for a rectangle, the area is length times width. So it's going to be 6 times 5, which equals 30. But remember, because there's 2, you've got to multiply it by 2. So 60. So, 60 centimeters squared. Because 6 times 5 is 30. Okay, and I'm multiplying it by 2 because there's 2 rectangles. Next one is the green. Okay, let's do the green. So that's that. Now let's add the green rectangles. Again, I can see that there are 2 green rectangles there. So multiply it by 2. Now with the green ones, I know that the length is 6. So this is 6. Okay, so that's going to be 6. But then what is the width? According to this, the width is 3. Okay, because this length should correspond with that length. Okay, so 6 by 3. So it's going to be length times width, which equals 6 times 3, which equals 18. Multiply it by 2 because there's 2 rectangles, and that will equal 36. Okay, so that's the second lot of the rectangles. Now the third one is these blue ones up here. Okay, so let's draw them. Now you technically don't have to do it this way. This is just a long way because some of you guys, what I've noticed in year 10 is you do find that it's easier to visualize the shapes. So that blue rectangle, what are the dimensions? Well, I can see that this is 3. Okay, so this length is 3. And this length here should technically be 5 as well because it attaches to this. So it's 3 by 5. Not to scale, yeah? So as you can see, that's 5, that's 3. Obviously, the shape doesn't look good. It's going to be different, but that's all right. And you know that there's 2 of them. Okay, so adding that, it's going to be length times width. So that's going to be 5 times 3, which equals 15. And then multiply it by 2 because there's 2 sides. Oh, there's 2 rectangles, sorry. So that equals 30. So when you add them all together, okay, as a final answer, 60 plus 36 plus 30 equals 126 centimeters squared. Okay, so that's the total area of this shape. Now, you might be thinking, Mr. Torre, that's a lot of work. I can't be bothered doing that. There is actually a quick formula to doing this. Okay? And the formula for it is, I don't know if it shows you here. Nope. Okay, I'll write down the formula for it here. So what I want you to do is write down the formula here for finding a rectangular prism. Okay, it's basically this. Actually, let me show it to you here, then I'll write it. It's basically just this. All of this. Okay, length times width. One thing I didn't include there is that times 2. So you got a times 2 for all of it. Okay, that's basically the formula for it, and you're just adding them all together. So the formula then for a rectangular prism, so write this down because you will need it. Length times width. So that's for one shape, plus length times width. That's the other rectangular side, plus length times width times 2. Okay, so that's the formula for a rectangular prism. Okay, the formula for any rectangular prism. We use this formula. Now, one thing you got to be mindful of though is the L and the W's will be different for each one. It's not going to be the same all the time. Okay, it might depend on the shape. So that's something that you should be mindful of when you do these. Okay. It'll be a lot easier, I think, when we put this to practice as well. Let's do the next one. So we're going to skip this one. Let's just do these ones. Okay, so for these, there's also formulas and there's nets that we can use. So for a triangular prism, okay, this is the formula that you can basically use for it here. So you have to find the surface area of the bases, which are these guys, and then add in the area of the sides. Okay, if I was to put this in a formula, I would actually write it like this. So it's going to be base times height divided by 2 times 2. Okay, that's the triangles. And then add that to length times width plus length times width plus length times width. So this will be the other triangle, other rectangles. Okay, notice though that there will be actually different rectangles. They're not all going to be the same. So that's the formula that we can use for a triangular prism. If we did that as an example here, sorry, this is a bit whack, but for example here, you can see that they've used 2 times, okay, of the triangle there. So it's base times height. I know that's a bit funny there, but it should be base times height. So 3 times 4 divided by 2. That's what they've done for these triangles here. And then they've added these rectangles. Okay, so the first one is a 3 by 6. So you can see that 3 by the 6 there. The second one is a 5 by 6. So that's this one, 5 by the 6. And the third one is the 4 by 6, which is this one, 4 by 6. Okay, and that's how we got that. So if I was actually to put this in here, it'll be 3 times 4 over 2 times 2 plus 3 by 6 plus 5 by 6 plus 4 by 6. Okay, that's how I would use the formula right there. All right, cylinder. Okay, this one's a bit trickier. It just depends on the type of cylinder that you might have. So let's say, for example, here, you've got a cylinder. I might redraw it so you guys get it. There's my cylinder, okay? And it gives me the radius of 4 millimeters. And you have a height of 3 millimeters. Okay, that's what my cylinder looks like. To find the area of it, or the surface area, okay, all you're doing basically is you can actually just use that formula right there. Okay, 2 times pi radius squared plus 2 times pi RH. All right, you can actually use that. So if I apply that here, 2 times pi times radius squared plus the other half of that formula is 2 times pi times RH. So 2 times pi times radius times the height. So if I actually apply that here, it's going to be 2 times pi times the radius here of 4. So 4 squared plus 2 times pi times the radius of 4 times the height of 3. Okay, so if I apply that formula, I'll get an answer of 175.8. All right, so essentially, highlight this because this is what you'll use. Okay, highlight that formula for your cylinder. Oh, you can't see that. Okay, that's the cylinder formula. So there's 3 formulas that you can actually use here. You've got your rectangular prism formula, which is that. You've got your triangular prism formula, which is this. Okay, that's the formula for your triangular prism. And then you've got your cylinder formula, which is that one right there. So those 3 formulas you will need to use when you're trying to find surface areas of certain shapes.